the aim of this video is to understand the significance of the discriminant. And you know that the discriminant is the expression that is equal to b squared minus 4ac, and that is related to a quadratic of the form ax squared plus bx plus c, where a is not 0. We will be considering the case where the coefficients, the a, b, and c, belong to the set of rational numbers. Let's consider the quadratic equation x squared minus 3x minus 10 equals to 0. And let's say that we want to solve it. We know that we can solve it by factorization. So we can factorize the left-hand side. We get x minus 5 times x plus 2, that equals 0. And using the null factor law, we know that x equals either 5 or 2, or negative 2, I mean. So the solutions, or what we call the roots, root here means the solution, is the value of x that makes the factor equal to 0. It is not this 5. It is the value of x that makes this whole thing a 0, and that's why it's 5. And that's why it's negative 2 here. A key point is that you need to note the relation between the existence of a linear factor and the roots. Here we have a root, a solution, and here we have a factor, and there is a connection between the two. If there is a factor, there is a root. If there is a root, there is a factor. This correspondence must be clear at all times. If we look at another quadratic, or another method of solution of quadratics, we can solve this graphically. But in this case, we will have to draw the curve y equals x squared minus 3x minus 10. And then we will look for a solution when y equals 0, i.e. that's where the curve crosses the x-axis. We can create a table of values. So when x is negative 3, y is 8. When x is negative 2, y is 0, and so on. And we can plot these points on a pair of Cartesian coordinates and then connect them using a smooth curve. This is the curve of a quadratic. It's called a parabola, and this is the line where y equals 0, that is the x-axis, and obviously your first root is negative 2 and your second root is 5. Again, the roots are the solutions. It has nothing to do with square roots. However, if we look at another quadratic, x squared minus 8x plus 16 equals 0, and we factorize it, try to solve it by factorization, the factorization of the left-hand side is x minus 4 all squared. It's a perfect square. So the solution is 4. This is the case where we have repeated factors, because here we have x minus 4 times x minus 4. That's why we call it a repeated factor. And even though our solution is only 4, we say that we have two identical roots, or two identical solutions. And if we draw the curve of y equals x squared minus 8x plus 16, we will find that the curve just touches the x-axis at the point where x equals 4, makes a tangent to the x-axis, and that's why we have a repeated root. There's only the 4. Now let's consider this quadratic equation. X squared plus 5x plus 3 equals 0. Can we factorize it? Can we find two factors with the signs here are plus and plus? We want two numbers whose product is 3 and whose sum is 5. You can try, but you won't find any. If we draw the curve, we find that this curve does not cross the x-axis. So, since there is no intersection, it means that there are no real solutions, no real roots for this quadratic. And since there are no real solutions, this implies that there are no linear factors. Previously, we could find the factors and then we could find the roots. Here, it's obvious that there are no roots. Obviously, there are no factors. So there are three possibilities for the solution of a quadratic equation. It may have two distinct real roots, such as in this case. It might have one repeated root, or it may have no real roots. Now, quadratics can also be solved by using the formula, which you'll remember is given that the quadratic is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. But then we have given this expression a name. B squared minus 4ac is the discriminant. So x is equal to negative b plus or minus the square root of the discriminant divided by 2a. And if we keep this expression in mind, then we can make the following conclusions. If the discriminant, if this value under the root is positive, then we will have two distinct real solutions, i.e. two intersections with the x-axis, and the left-hand side of the quadratic will have two linear factors. For example, if the discriminant is, say, 16, then your x would be negative b plus or minus the square root of 16 divided by 2a. Plus minus 16 is negative b plus or minus 4 divided by 2a, and hence you have two solutions, one for negative b plus 4 divided by 2a, and the other for negative b minus 4 divided by 2a. So this is the reason that when the discriminant is greater than 0, we have two solutions, i.e. two intersection with the x-axis, i.e. two linear factors. However, if the discriminant is equal to 0, we will have only one solution, which is the case where we saw the curve making a tangent with the x-axis, and we have two repeated factors. Just imagine that here the discriminant is equal to 0, this whole thing will disappear. Minus b plus or minus 0 divided by 2a is simply minus b over 2a. And finally, if the discriminant is less than 0, then we will have a negative under the square root, and obviously there's no real solution for that case, and that implies that there's no intersection with the x-axis and no linear factors. So this is the first level of the significance of the discriminant. It tells us, its sign tells us how many solutions we have. If it's positive, we have two solutions. If it's 0, we have one solution, and if it's negative, we have no solutions. Let's look at this example. When solving 3x squared minus 2x plus 9 equals 0, we may begin by identifying the values of a, b, and c, and then working out the value of the discriminant. Once done, we will find that this discriminant is less than 0. This implies that there are no real roots, no real solutions. And at the same time, since there are no real solutions, then the quadratic cannot be factorized, and saves us a lot of time and effort. Let's consider another case. 4x squared plus 12x plus 9 equals 0. Identifying a, b, and c and calculating the discriminant, we find that the discriminant is equal to 0. This implies that we have one repeated real solution, and the expression can be factorized and will contain two identical linear factors. And if you think about it, then the two factors are 2x plus 3 all squared equals to 0, and x equals negative 3 over 2. Again, if we consider x squared plus 5x minus 14 equals 0, we identify A, B, and C, calculate the discriminant, and we find that the discriminant is positive. Thus, it has a positive value, and that means that there are two distinct real solutions. But since the discriminant is a perfect square, it means that the two roots are rational and the expression is easy to factorize, and that's a very important extra piece of information. Let's see what this means. Using the formula, x is equal to negative b plus or minus the square root of 81, which is the square root of the discriminant, divided by 2a, which is 2. This is negative 5 plus or minus 9 divided by 2. Taking the positive, negative 5 plus 9 is 4, divided by 2 is 2, or negative 5 minus 9 is negative 14, divided by 2, that's negative 7. Those two roots are rational because since this is a perfect square, we can only get an integer here, and if we're dividing the sum of integers by another integer, we can only get a rational number. And with rational numbers, we can think about the mathematics behind it, the arithmetic, and we can factorize this expression. The fact that this is 81 is a perfect square, then it tells me that I can factorize this expression, and it's x plus 7 times x minus 2 equals 0. It's an indication that factorization is easy. Let's consider this quadratic, x squared plus 5x minus 10. We identify A, B, and C. We work out the discriminant. The discriminant is 65. It's positive. It means that we have two solutions. Two distinct solutions, and therefore two linear factors. But the discriminant is not a perfect square. It means that the roots are irrational and the expression is not easy to factorize. Let's do the calculation. X is equal to negative b plus or minus the square root of 65 divided by 2a, which is 2. And 65 is irrational. So when you work out negative 5 plus or minus 65 divided by 2, you will obviously get an irrational number. And if we calculate this value, we get the following two answers. X equals the irrational number of 1.5311, etc., or x equals negative 6.5311, etc. Two irrational numbers. So there are two roots and there are two factors, but it is impossible for us to think about the two factors that generate those two solutions. Who on earth would be able to work out that the left hand side is equal to x minus 1.5311, etc., times x plus 6.5311, etc., equals 0. There is no way that a human being can think that this times that is negative 10 and this plus that is 5. So this tells us that when the discriminant is not a perfect square, then the roots are irrational and the expression is not easily factorizable by us, even though the two factors may exist. So as a summary, we can add to this previous work that we have done the two special cases when the discriminant is positive. If the discriminant is a perfect square, then we have rational roots and we can factorize the expression easily. If the discriminant is positive still, but not a perfect square, then the roots are irrational and the expression is not easy to factorize. I know there's a lot in this video. You may want to watch it again, or you may want to take notes and refer to them every once in a while.